Okay, so we have another advanced math hard level. This is about nonlinear functions. And let's take a look. The growth of a culture of bacteria. We're given a number of days as an independent variable, and the number of bacteria per milliliters at the end of the day. A culture of bacteria is growing at an exponential rate. So let's stop there for a moment. Exponential function in general form will look like y equals a b to the power of x. As shown in the table above, at this rate, on which day would the number of bacteria per milliliter reach 5.12 times 10 to the 8th? Okay. So let's first determine the value of b here. So what's the growth vector? If you look at from day 1 to day 2, you can notice that the power of 10 is still the fifth, so it doesn't change. However, it does double. 2.5 to 5.0 is twice as much. So let's conclude that b is equal to 2, and we can rewrite it as y equals a 2 to the power of x. And for x, let's say x is a number of days. And we need to find the a here. Now, unfortunately, there's no day 0. There's no day 0. So, however, you can just trace it backward. So if it doubles each day, if you go from day 1 to day 0, it gotta go half. Is that clear, everybody? When day equals 0, we should have 1.25 times 10 to the 5th. Because at the rate it's growing exponentially by doubling, 1.25 on the initial day times 2 will give you day 1, 2.5 times 10 to the 5th. So careful, the day 1 is like at the end of day 1 here. The day 0 is when you first started it. Okay, so otherwise you'll be off by 1, and that's what's so tricky about this question. So I determined the initial amount of the initial volume in milliliter. So yes, okay, yeah. So it said at the end of the day. That's the tricky part. Okay, at the end of day 1, you had this much. So initially, you should have 1.25 times 10 to the 5th and 2 to the x. Because when you plug it in x equals 0, then it will give you the amount. Okay, so now we got the formula. We just set the y equals 5.12 times 10 to the power of 8. And we need to find what x is. There are many ways you can do this. However, SAT really doesn't ask you the log. So that might be overkill here. But if you want to use it, go ahead. So I divide both sides by the 1.25 times 10 to the power of 5th. This way I have 2 to the x on the right. And on the left, I get 10 to the 3rd powers. If you just do 10 to the 8th over 10 to the 5th. All you need to do is subtract the bottom exponent from the top. You get 3. And then 5.12 divided by 1.25 will give us 4.096. So simply, if you move your decimal point 3 to the right by multiplying thousands, you get 4096 equal to 2 to the x. Now, if anyone remember playing video games such as 2048, you might remember that this is 2 to the power of 11, I think. Because 2 to the 10 equals 1024. So 2 to the 11, I'll double check. 2 to the 11 give you that amount. And if you go one more, 2 to the 12 will give you 4096. So if you write it at 2 to the power of 12 equals 2 to the x, then x equals 12. So on which day? So on day 12, you will reach that amount. So that's why the answer is D. Now, if you don't take that approach, You might need to put, all right, you might have to put just natural log or log. Okay, you can just use log. And by using the product property of log, bring the x downward. And just divide log of 2 on both sides. Then x equals log of 4096 divided by log of 2. And when you put that in your calculator, log of 4096 divided by, okay, very common mistake, do not just divide like that, okay? I mean, you cannot do this, okay? You gotta actually put both log 4096 divided by log of 2, and now we got 12. Okay, either way is gonna work. Thank you for watching, and if you like my video, please subscribe. Thank you very much.